You've learned a lot about how BI professionals ensure that their organization's database systems and tools continue to be as useful as possible. This includes evaluating whether fixes or updates are needed and performing optimization when necessary. Previously, we focused specifically on optimizing database systems. Now, it's time to explore optimizing pipelines and ETL processes. In this section of the course, you'll learn about ETL quality testing, data schema validation, verifying business rules, and general performance testing. Through ETL quality testing, BI professionals aim to confirm that data is extracted, transformed, and loaded to its destination without any errors or issues. This is especially important because sometimes your pipeline might start producing bad or misleading results. This can happen when the original sources are changed without your knowledge. Also, we'll soon cover data schema validation, which is used to keep source data aligned with the target database schema. A schema mismatch can cause system failures, so this is critical to keeping the ETL running smoothly. We'll also investigate data integrity and how built-in quality checks defend against potential problems. Finally, we'll focus on verifying business rules and general performance testing to make sure the pipeline is fulfilling the business need it was intended to. There's a lot to come, so let's begin exploring the optimization processes for pipelines and ETL. You're already familiar with ETL pipelines, where data is extracted from a source, transformed while it's being moved, and then loaded into a destination table where it can be actioned on. Part of the transformation step in the ETL process is quality testing. In BI, quality testing is the process of checking data for defects in order to prevent system failures. The goal is to ensure the pipeline continues to work properly. Quality testing can be time-consuming, but it's extremely important for an organization's workflow. Quality testing involves 7 validation elements: completeness, consistency, conformity, accuracy, redundancy, integrity, and timeliness. That's a lot of elements to keep in mind, but we're going to break down each in this video, starting with completeness. Also, you may recall some of these concepts from the Google Data Analytics certificate. If you'd like, take a few minutes to review that content before moving ahead. All right, let's start with checking for completeness. This involves confirming that the data contains all desired components or measures. For example, imagine you're working with sales data and you have an ETL pipeline that delivers monthly data to target tables. These target tables are used to generate reports for stakeholders. If the data being moved through the pipeline is missing a week of data, or information about one of the best-selling products, or another key metric, then the calculations used to create reports won't have complete, accurate data. Next, we have consistency. You might have learned that, in a data analytics context, consistency deals with the degree to which data is repeatable from different points of entry or collection. In BI, it's a bit different. Here, consistency involves confirming that data is compatible and in agreement across all systems. Imagine 2 systems. One is an HR database with employee data, and the other is a payroll system. If the HR database lists an employee who either isn't in the payroll system or is listed differently there, that inconsistency could create problems. Next is conformity. This element is all about whether the data fits the required destination format. Consider sales data in an ETL pipeline. If the data being extracted includes dates of sale that don't match the dates that the destination table is designed to hold, that's going to create errors. Now, accuracy has to do with the data conforming to the actual entity that's being measured or described. Another way of thinking about this is if the data represents real values. So with that in mind, any mistyped entries or errors from the source are problematic because they will be reflected in the destination. Source systems requiring a lot of manual data entry are more likely to have issues with accuracy. Like if a purchase of a hamburger was misentered as selling for $1 million, that's something you need to take care of before the data is loaded. If you're using a relational storage database, ensuring that there isn't any redundancy in the data is another important element of quality testing. In a BI context, redundancy is moving, transforming, or storing more than the necessary data. This occurs when the same piece of data is stored in 2 or more places. Moving data through a pipeline requires processing power, time, and resources. So it's important not to move any more data than you need. For instance, if client company names are listed in multiple places, but are only required to appear in one place in the destination table, we wouldn't want to waste resources on loading that redundant data. Now we come to integrity. Integrity concerns the accuracy, completeness, consistency, and trustworthiness of data throughout its lifecycle. In quality testing, this often means checking for any missing relationships in the data values. As an example, say a company's sales database is relational. BI professionals would depend on those relationships to manipulate data within the database and to query the data. Maybe they have product IDs and descriptions in a database, but if there's a description and no corresponding record with the ID, there's now an issue with data integrity. It's essential to make sure this is addressed before moving on to analysis. Data mapping is one way to make sure that the data from the source matches the data in the target database. You'll learn more about this later, but basically, data mapping is the process of matching fields from one data source to another. Last but not least, you want to make sure your data is timely. Timeliness involves confirming that data is current. This check is done specifically to make sure data has been updated with the most recent information that can provide relevant insights. For example, if a data warehouse is supposed to contain daily data, but doesn't update properly, then the pipeline can't ingest the latest information. BI professionals are mostly interested in exploring current data in order to allow stakeholders to gain the freshest insights. This definitely won't be possible if the data being moved is already outdated. A lot goes into ETL quality testing, and it can be a tricky process. But remembering these 7 key elements is a wonderful first step toward creating high-quality pipelines. Coming up, you're going to learn even more about these checks and other performance tests for ETL processes. Bye for now.
My name is Mana, and I am a Senior Technical Data Program Manager at Google. And what that means is that I work with business partners and I help create tools that help enable them to make better decisions with data. I'm a big data nerd, so I love playing around with data and getting to build cool stuff that makes people's jobs a lot easier. So there's a common saying that in the absence of data, you have dirt. And I like to take that a step further. I like to say in the absence of good data, you have dirt. Quality testing is all about how do you make sure that you have good data. And good data can mean a number of different things. Oftentimes it means accurate data. So how do you ensure that the numbers you're producing are correct and they're representative of the truth? It can also mean relevant data. It can also mean representative data. It can also mean quick data at your fingertips, right? So the process of quality control is making sure that the tools that you're building with respect to data are accurate, helpful, relevant, and timely. There are many times across the life cycle of building a BI product in which quality testing comes into play. So if you think of the very early stages where maybe someone is trying to extract data from logs, you're going to want to make sure that the data that you're extracting is accurate. So is the same data that's coming in through the logs the same data that's being spit out from the data mart maybe that I'm creating? It's the same idea through your ETL processes, where ETL means extract, transform, and load. So as you're grabbing the data, you're transforming it, you're massaging it, and you're creating relevancy with that data, you want to make sure that the data you got in is the same data you're spitting out. I remember when I was a young professional, I was always imagining that one day I would land at a company that was data nirvana and all of their data would be so clean and so perfect and it was just magical. I could just query it with no worries in the world. And the truth is that nirvana does not exist anywhere. Data always has issues. There are always bugs that come up. Even the data that you were looking at today might be different than the data that you look at tomorrow. So embedding quality testing not only as a one-off, but as a regular process in your pipelines or in whatever that you're building is of incredible importance because bugs are just bound to happen. There are a couple of things that I wish I knew when I was starting out. I wish that I had fully been able to recognize how many skills I had in this department that came from other parts of my life and weren't the traditional means of BI skills. And with that, having more confidence in myself, because I came in with really fantastic storytelling skills that I was really able to hone in on. And even though I wasn't a software engineer, I had a lot of experience coding, and I knew a lot of best practices that I was able to put in place. So I would say that if there are areas that you feel like you're maybe not the strongest in, that if you stay curious and you stay open and you stay humble and you find folks that are really great at those and you ask them, hey, how do you do that? Know that you can learn and you can grow in those capacities and you can become continuously well-rounded. It's very normal for us as humans to have our strengths and our growth areas, but being successful is not having them innately. It's having the ability to constantly evolve, better yourself, and not become the expert, but just become better than you were yesterday.
You're learning a lot about the importance of quality testing in ETL. And you now know that a key part of the process is checking for conformity, or whether the data fits the required destination format. To ensure conformity from source to destination, BI professionals have 3 very effective tools: schema validation, data dictionaries, and data lineages. In this video, we'll examine how they can help you establish consistent data governance. First, schema validation is a process to ensure that the source system data schema matches the target database data schema. As you're learning, if the schemas don't align, this can cause system failures that are very difficult to fix. So building schema validation into your workflow is important to prevent these issues. Database tools offer various schema validation options that can be used to check incoming data against the destination schema requirements. For example, you could dictate that a certain column contains only numerical data. Then, if you try to enter something in that column that doesn't conform, the system will flag the error. Or, in a relational database, you could specify that an ID number must be a unique field. That means the same ID can't be added if it matches an existing entry. This prevents redundancies in the data. With these properties in action, if the data doesn't conform and throws an error, you'll be alerted. Or, if it meets the requirements, you'll know it's valid and safe to load. Schema validation properties should ensure 3 things. The keys are still valid after transformation, the table relationships have been preserved, and the conventions are consistent across the database. Let's start with the keys. As you've been learning, relational databases use primary and foreign keys to build relationships among tables. These keys should continue to function after you've moved data from one system into another. For example, if your source system uses customer ID as a key, then that needs to be valid in the target schema as well. This is related to the next property of schema validation, making sure the table relationships have been preserved. When taking in data from a source system, it's important that these keys remain valid in the target system, so the relationships can still be used to connect tables, or that they are transformed to match the target schema. For example, if the customer ID key doesn't apply to our target system, then all of the tables that used it as a primary or foreign key are disconnected. If the relationships between tables have been broken while data is being moved, then the data becomes hard to access and use. And that's the whole reason we moved it to our target system. Finally, you want to ensure that the conventions are consistent with the target database's schema. Sometimes, data from outside sources uses different conventions for naming columns in tables. For example, you could have a source system that uses employee ID as one word to identify that field, but the target database might use employee_ID. You'll need to ensure these are consistent so you don't get errors when trying to pull data for analysis. In addition to the properties themselves, there are some other documentation tools that support data schema validation: data dictionaries and data lineages. A data dictionary is a collection of information that describes the content, format, and structure of data objects within a database, as well as their relationships. You might also hear this referred to as a metadata repository. You may know that metadata is data about data. This is a very important concept in BI, so if you'd like to review some of the lessons about metadata from the Google Data Analytics Certificate, go ahead and do that now. In the case of data dictionaries, these represent metadata because they're basically using one type of data, metadata, to define the use and origin of another piece of data. There are several reasons you might want to create a data dictionary for your team. For one thing, it helps avoid inconsistencies throughout a project. In addition, it enables you to define any conventions that other team members need to know in order to create more alignment across teams. Best of all, it makes the data easier to work with. Now, let's explore data lineages. Data lineage describes the process of identifying the origin of data, where it has moved throughout the system, and how it has transformed over time. This is useful because if you do get an error, you can track the lineage of that piece of data and understand what happened along the way to cause the problem. Then, you can put standards in place to avoid the same issue in the future. Using schema validation, data dictionaries, and data lineages really helps BI professionals promote consistency as data is moved from the source to the destination. And this means all users can be confident in the BI solutions being created. We'll keep exploring these concepts soon. One of the best ways to learn is through a case study. When you witness how something happened at an actual organization, it really brings ideas and concepts to life. So in this video, we're going to check out schema governance in action at an educational nonprofit. In this scenario, decision makers at the nonprofit are interested in measuring educational outcomes in their community. In order to do this, they are ingesting data from school databases in order to evaluate learning goals, national education statistics, and student surveys. Because they're pulling data from multiple sources into their own database system, it's important that they maintain consistency across all of the data to prevent errors and avoid losing important information. Luckily, this organization already has a data dictionary and lineage in place to establish the necessary standards. Let's check out an example of a column from the student information table. This table has 5 columns: student ID, school system, school, age, and grade point average. Each column in this table has been recorded in the data dictionary to specify what information it contains. So we can go to the data dictionary entry for the school system column to double-check the standards for this table. As a refresher, a data dictionary is a collection of information that describes the content, format, and structure of data objects within a database and their relationships. This dictionary records 4 specific properties: the name of the column, its definition, the data type, and possible values. The dictionary entry for age lets us know that data objects in this column contain information about a student's age. It also tells us that this is integer-type data. We can use these properties to compare incoming data to the destination table. If any data objects aren't integer-type data, then the schema validation will flag the error before the incorrect data is ingested into the destination. So, what happens when a data object fails this schema validation process? We can actually use the data lineage to trace the journey of this piece of data and find out where in the process we might want to add a quality check. Again, a data lineage includes information about the data's origin, where it has moved throughout the system, and how it has transformed over time. During the schema validation process, this piece of data threw an error because it isn't currently cast as integer type. When we check the data lineage, we can track this object's movement through our system. This data started in an individual school's database before being read into the school system's database. The individual school's data was ingested by our pipeline along with data from other school systems, and then organized and transformed during the movement process. Apparently, when this data was input in the school's original database, it wasn't typecasted correctly. We can confirm that by checking its data type throughout the lineage. The lineage also includes all the transformations that this data has undergone so far. Also, we might at this point notice that typecasting isn't built into our transformation process during quality checks. That's great news. Now we know that that's a process we should incorporate into the pipeline before data is read into the destination table. In this case, age data objects should be integer type. And that's how schema governance and validation can help improve systems and prevent errors. There are other kinds of tests that should be applied to a pipeline to make sure it's functioning correctly, which we'll learn more about soon. But now you have a better understanding of how to validate the schema and keep improving your pipeline processes. So far, we've learned a lot about database performance, quality testing, and schema validation, and how these checks ensure the database and pipeline system continue to work as expected. Now, we're going to explore another important check: making sure that the systems and processes you have created actually meet business needs. This is essential for ensuring that those systems continue to be relevant to your stakeholders. To do this, BI professionals verify business rules. In BI, a business rule is a statement that creates a restriction on specific parts of a database. For example, a shipping database might impose a business rule that states shipping dates can't come before order dates. This prevents order dates and shipping dates from being mixed up and causing errors within this system. Business rules are created according to the way a particular organization uses its data. In a previous video, we discovered how important it can be to observe how a business uses data before building a database system or ETL process. Understanding the actual needs guides the design, and this is true for business rules too. The business rules you create will affect a lot of a database's design. What data is collected and stored, how relationships are defined, what kind of information the database provides, and the security of the data. This helps ensure the database is performing as intended. Business rules are different at every organization because the way organizations interact with their data is always different. Plus, business rules are also always changing, which is why keeping a record of what rules exist and why is critical. Here's another example. Consider a library database. The primary need of the users, who are librarians in this case, is to check out books and maintain information about patrons. Because of this, there are a few business rules this library might impose on the database to regulate the system. One rule could be that library patrons cannot check out more than 5 books at a time. The database won't let a user check out a 6th book. Or, the database could have a rule that the same book cannot be checked out by 2 people at the same time. If someone tries, the librarians would be alerted that there is a redundancy. Another business rule could be that specific information must be entered into the system for a new book to be added to the library inventory. Basically, verification involves ensuring that data imported into the target database complies with business rules. On top of that, these rules are important pieces of knowledge that help a BI professional understand how a business and its processes function. This helps the BI professional become a subject matter expert and trusted advisor. As you're probably noticing, this process is very similar to schema validation. In schema validation, you take the target database's schema and compare incoming data to it. Data that fails this check is not ingested into the destination database. Similarly, you will compare incoming data to the business rules before loading it into the database. In our library example, if a patron puts in a request for a book, but they already have more than 5 books from the library, then this incoming data doesn't comply with the preset business rule, and it prevents them from checking out the book. And that's the basics about verifying business rules. These checks are important because they ensure that databases do their jobs as intended. And because business rules are so integral to the way databases function, verifying that they're working correctly is very important. Coming up, you'll get a chance to explore business rules in more detail.
My name is Borak. I'm a BI engineer in Google. What a BI engineer does is actually collecting, storing, and analyzing data with a lot of infrastructure involved. I moved to States 5 years ago as a fresh immigrant, so it was very difficult to get the first job for me. Even though I have a degree, I still needed to a lot of training and get ready for the domestic needs of the market. I started teaching myself what a BI engineer does, what are the essential technical skills that I need to learn, and I did a lot of online research. I found a lot of free stuff. I found a couple of paid subscriptions, and I started learning all these technical skills that I need to learn to get my first job. BI technology evolved a lot over the last 10 years. I can say spreadsheets were a thing 10 years ago, but nobody uses spreadsheets anymore in terms of data analysis. I mean, it's still being used for quick analysis, but now everything has evolved into cloud technologies, more sophisticated languages, more powerful visual tools to help everyone. So personally, I have to adapt changing new environments and new languages and new infrastructures. In order to keep up with the technology, you actually need to do a little bit research and understand how the industry is actually evolving. There are a lot of online resources or web pages or newsletters that you can follow about the latest industry trends, but the essentials, they never change. The foundation of the BI engineering is the same. If you learn a SQL language, whatever organization you work for is going to be a different SQL language. It's going to be a different dialect. So you still need to catch up with. But the amount of time that you need to learn is going to be drastically less than the amount of time you first start, because there is going to be intransferable skills. My number one piece advice will be dedication. If you really love working with data and if you would like to work in this field, dedication is one of the key requirements, because there is a lot of technical skills that you need to learn and it needs time. Therefore, I recommend to identify which area of BI engineering that you actually want to focus on, because there are several parts that you can work. You can build infrastructures, or you can design systems, or you can analyze data, or you can do some visualization tools. Depending on which area you would like to focus on, the technical skills you need to learn will vary.
As a BI professional, your job doesn't end once you've built the database systems and pipeline tools for your organization. It's also important that you ensure they continue to work as intended and handle potential errors before they become problems. In order to address those ongoing needs, you've been learning a lot. First, you explored the importance of quality testing in an ETL system. This involved checking incoming data for completeness, consistency, conformity, accuracy, redundancy, integrity, and timeliness. You also investigated schema governance and how schema validation can prevent incoming data from causing errors in the system by making sure it conforms to the schema properties of the destination database. After that, you discovered why verifying business rules is an important step in optimization, because it ensures that the data coming in meets the business needs of the organization using it. Maintaining the storage systems that users interact with is an important part of ensuring that your system is meeting the business's needs. This is why database optimization is so important. But it's just as important to ensure that the systems that move data from place to place are as efficient as possible. And that's where optimizing pipelines and ETL systems comes in. Coming up, you have another assessment. I know you can do this. And just as a reminder, you can review any of the material as you get ready, as well as the latest glossary. So feel free to revisit any videos or readings to get a refresher before the assessment. After that, you'll have the chance to put everything you've been learning into practice by developing BI tools and processes yourself. You're making excellent progress toward a career in BI.
Welcome back. In this video, we're going to discuss data integrity and some risks you might run into as a data analyst. A strong analysis depends on the integrity of the data. If the data you're using is compromised in any way, your analysis won't be as strong as it should be. Data integrity is the accuracy, completeness, consistency, and trustworthiness of data throughout its life cycle. That might sound like a lot of qualities for the data to live up to, but trust me, it's worth it to check for them all before proceeding with your analysis. Otherwise, your analysis could be wrong. Not because you did something wrong, but because the data you were working with was wrong to begin with. When data integrity is low, it can cause anything from the loss of a single pixel in an image to an incorrect medical decision. In some cases, one missing piece can make all of your data useless. Data integrity can be compromised in lots of different ways. There's a chance data can be compromised every time it's replicated, transferred, or manipulated in any way. Data replication is the process of storing data in multiple locations. If you're replicating data at different times, in different places, there's a chance your data will be out of sync. This data lacks integrity because different people might not be using the same data for their findings, which can cause inconsistencies. There's also the issue of data transfer, which is the process of copying data from a storage device to memory, or from one computer to another. If your data transfer is interrupted, you might end up with an incomplete data set, which might not be useful for your needs. The data manipulation process involves changing the data to make it more organized and easier to read. Data manipulation is meant to make the data analysis process more efficient, but an error during the process can compromise that efficiency. Finally, data can also be compromised through human error, viruses, malware, hacking, and system failures, which can all lead to even more headaches. I'll stop there. That's enough potentially bad news to digest. Let's move on to some potentially good news. In a lot of companies, the data warehouse or data engineering team takes care of ensuring data integrity. Coming up, we'll learn about checking data integrity as a data analyst. But rest assured, someone else will usually have your back too. After you found out what kind of data you're working with, it's important to double-check that your data is complete and valid before analysis. This will help ensure that your analysis and eventual conclusions are accurate. Checking data integrity is a vital step in processing your data to get it ready for analysis, whether you or someone else at your company is doing it. Coming up, you'll learn even more about data integrity. See you soon.
Now that you understand the different ways to organize data in a database, let's talk about how you can describe that data. In this video, we'll start exploring metadata, which is a very important aspect of database management. Metadata is kind of an abstract concept, though. So let's kick things off with a simple, everyday example. Did you know that every time a photo is taken with a smartphone, data is automatically collected and stored within that photo? Take a look. Choose any photo on your computer. Here's a cute shot of my friend's dogs, Rudy and Matilda. On your photo, right-click on Get Info or Properties. This will give you the photo's metadata, which may tell you the type of file it is, the date and time it was taken, the geolocation or where it was taken, what kind of device was used to take the photo, and much more. Pretty amazing, right? Here's another example. Every time you send or receive an email, metadata is sent right along with that message. You can find it by clicking on Show Original or View Message Details. An email message's metadata includes its subject, who it's from, who it's to, and the date and time it was sent. The metadata even knows how quickly it was delivered after the sender pressed send. Okay, so metadata is information that's used to describe the data that's contained in something, like a photo or an email. Keep in mind that metadata is not the data itself. Instead, it's data about the data. In data analytics, metadata helps data analysts interpret the contents of the data within a database. That's why metadata is so important when working with databases. It tells an analyst what the data is all about. That makes it possible to put the data to work solving problems and making data-driven decisions. As a data analyst, there are 3 common types of metadata that you'll come across: descriptive, structural, and administrative. Descriptive metadata is metadata that describes a piece of data and can be used to identify it at a later point in time. For instance, the descriptive metadata of a book in a library would include the code you see on its spine, known as a Unique International Standard Book Number, also called the ISBN. It would also include the book's author and title. Next is structural metadata, which is metadata that indicates how a piece of data is organized and whether it's part of one or more than one data collection. Let's head back to the library. An example of structural data would be how the pages of a book are put together to create different chapters. It's important to note that structural metadata also keeps track of the relationship between 2 things. For example, it can show us that the digital document of a book manuscript was actually the original version of a now printed book. Finally, we have administrative metadata. Administrative metadata is metadata that indicates the technical source of a digital asset. When we looked at the metadata inside the photo, that was administrative metadata. It showed you the type of file it was, the date and time it was taken, and much more. Here's one final thought to help you understand metadata. If you're on your way to the library to pick out a book, you could research a book's title, author, length, and number of chapters. That's all metadata, and it can tell you a lot about the book. But you have to actually read the book to know what it's all about. Likewise, you can read about data analytics, but you have to take this course to earn the Google Data Analytics certificate. So keep moving forward to gain that new perspective.